Solar shading. So sunlight emitted into a building impacts on the building energy consumption in different ways, in different seasons. So the sun path is different would be different in the summer or in the winter. So in the summer, excessive solar heat gain results in greater energy consumption due to the increased cooling load requirement. And in the winter, sunlight reaching the south facade can provide passive solar heating. So in the winter, sunlight is more welcome. We want sunlight more. And in all seasons of the year, the sun improves daylight quality. So I think in Hong Kong, sunlight is welcome in the winter, but in the summer, we don't really want sunlight. But for daylight or for skylight, okay, for skylight, it is always welcome. Well-designed shading devices can significantly reduce building peak cooling load and correspond energy consumption and enhance daylight utilization in buildings. So solar shading is used to block the unwanted sunlight so that the peak cooling load can be reduced and the energy consumption in the air conditioning system can also be reduced. Shading devices can also avoid glare by reducing contrast ratio of building interior. So glare is a term used to describe the visual discomfort due to the extreme contrast in the visual field. So for the sunlight, it is very, very strong, or the window is usually much brighter than the interior walls. Then it may create glare. Shading of external windows can be provided by natural landscaping, such as tree, hills, or by building elements such as overhang, awnings, fins, and trellises. So for Hong Kong, we have many high-rise buildings. So I think it is not too practical to use natural landscaping such as tree or other elements to provide shadings. So we need to rely on the overhang or some vertical fins. So like in this picture, these are some recommended external shading for different orientation. Okay, so like for east and west, we may use these vertical fin. Okay, these vertical side fins, because the sunlight in the east or in the west, they usually comes from lower angle, but may not be exactly east or west. So we may use these fins to block the sunlight which is coming at a low angle, and then these can have a certain tilting angle so as to block these low angle sunlight. So just like this is the top view, okay, top view, and this is the east direction, okay. So if you want to block the sunlight coming from the east, then maybe you can use the vertical fins like this. Okay, then it can block the low angle sunlight coming from the east. Okay, so for blocking low angle, we will the sunlight at low angles, we will use vertical fins, and to block the sunlight comes from high angle, like the south, we will use the you will use the horizontal overhang. Okay, these are some examples for the sunshades and reflector. So if you design it very well, then these solar shadings can be a kind of architectural features to the building. Window and glazing. Okay, glazing is an important element in buildings. It offers daylighting and ventilation for building interior. A number of studies show that health, comfort, and productivity of building occupants are improved due to well-ventilated indoor environment and access to natural light. So we have learned that daylight is the most healthy to human, and we also live more healthily and happily when we have natural ventilations. However, windows also represent the major source of heat gain or heat loss, visual or thermal discomfort. In residential and commercial buildings, a considerable amount of energy has been used to compensate the unwanted heat gain or loss through windows. So window is treated as a kind of weakness in the building facade. So you may have a very well-insulated walls, but the window is an opening. So it is the weak point, and there could be leakage in the windows. There could be condensation. There could be noise. So noise transmitted through the window, so it is a weak point. Windows have undergone a technological revolution in recent years. Energy-efficient windows and glazing systems are now available that can dramatically cut building energy consumptions. These high-performance window features high-performance windows feature multiple glazing, specialized transparent coating, insulating gas in between gas panes, and improved frame. Okay, multiple glazing. So we may have double glazing or even triple. So it provides extra ventilation, extra insulation, extra heat insulation. Specialized transparent coatings. So this coating is able to reflect or filter the unwanted wavelength or the unwanted spectrum. So daylight consists of a continuous spectrum. Apart from the visible spectrum, we also have the ultraviolet and also the infrared light. But the ultraviolet light and the infrared may not be too welcome. Okay, for the infrared, it will result in heat, and for the ultraviolet, it may affect the furnishing of the interior. It may affect the furniture, the furnishing of the interior. So we may want to cut out the IR and the UV and leave only the visible light. So there are certain type of transparent coating and filters. These glazing can be able to filter the unwanted wavelength. Insulating gas in between glass panes. So similarly, it is to provide extra insulation. So all these features reduce heat transfer, thus able to cut energy burden due to window openings. Okay, so these are some examples. The low E glass. So this picture is the low E glass. And this picture is the gas-filled glazing. So in between the layers of glasses, inside the layer, it is gas. So some kind of gas or some gel that is transparent, but at the same time, it is able to provide insulation, thermal insulation. So for air-conditioned buildings in Hong Kong, the temperature difference between indoor and outdoor environment could be large in summer. So in the summer, outside 35 degrees, and inside the interior 25. So 10-degree difference, which is quite big. So the building should be insulated well so that the heat transfer from the outside to the interior can be minimized. And then the electricity consumption for the air conditioning system can also be reduced. So appropriate choice of windows with low thermal transmittance characteristics, like the multiple glazing, specialized transparent coating, insulating gas in between glass panes, will also minimize solar heat transmission. Okay, some other examples of the glazing. We have the reflective glazing. So reflective glazing is very common for the curtain wall buildings, the commercial buildings, the high-rise office building in Hong Kong. Reflective glasses usually consist of thin metallic coating that helps control solar heat gain. However, reflective glass typically blocks more light than heat. So these reflective coating will also reflect away the visible light. Okay, the second type, insulated glazing. Insulated glazing typically refers to double or triple glazing, where two or more panes are spaced a distance apart and hermetically sealed, creating an insulating air space in between each pane. Okay, so it could be vacuum or not vacuum. So anyway, this double glazing, triple glazing provides an extra insulation. Gas-filled glazing. So in gas-filled double or triple glazed windows, instead of air, the space is filled with argon or krypton gas, which provides a superior resistance to heat flow. Okay, some more examples of the high-performance glazing. Spectrally selective glazing. Spectrally means about the wavelength, the spectrum. So a type of window glass. So spectrally selective glazing is a type of window glass that permits some portions of solar spectrum to enter a building while blocking others. So we want to transmit the visible spectrum, but block the infrared and the ultraviolet light. So it screens out or reflect the heat-generating ultraviolet and infrared radiation arriving at the building's exterior surface while permitting the most visible light to enter. And the second type is the electrochromic glazing. So this is a very interesting glazing. So as shown in this picture, outside is very bright. So the glazing, they turns into like a sunglasses. Okay, the transmittance reduced, so it becomes like a tinted glass. So electrochromic glazing is a glass or glazing whose light transmission properties are altered when voltage, light, or heat is applied. So generally, the glass changes from translucent to transparent, changing from blocking some wavelength of light to letting light pass through. So when it is when the lighting level is not too high, then maybe this windows will be transparent. But when the outside is very sunny, so the amount of light received by the exterior surface is high, then the transmittance becomes lower so as to block the unwanted daylight. Okay, so this is just a table comparing different type of glazing. So we have double glazing with coating, single glazing with coating, low emission, double glazing, single glazing without coating. So single glazing without coating, this is probably the window type for most of the residential buildings in Hong Kong. So just an ordinary glass. And then this is the low E glass and the single glazing with coating. Okay, and double glazing with coating. Ventilated double layer glass wall. So it is not too common in Hong Kong. The double skin facade is a system of building consists of two skin. So in this picture, we have one layer and then two layer, so double layer. The ventilation of the cavity can be natural, fan supported, or mechanical. So inside the two layer, there will be air flowing, and the air flow could be naturally. Okay, hot air rise so that air naturally flow upward, or maybe there could be a fan driving the air to flow through the cavity. So the outside sunlight may heat up the air inside the cavity, and naturally or maybe mechanically the air can be flow away so that the air being heated by the sunlight can be extracted away from the cavity. So it can reduce the heat gain to the interior. Criticism. So this double layer, double skin facade system is not too common in Hong Kong is because the cavity results in decrease in usable floor area. And in Hong Kong, floor area is very expensive. Okay. And depending on the strategy of ventilating the cavity, it may have problems with condensation. Okay, condensation becomes soiled or introducing outside noise. The construction of second skin may also present a significant increase in material and design costs. So these are some problems of the double layer facade system. Selection of materials. The use of materials for building construction causes major impacts on the environment. So you can imagine how much materials we have spent on the building. And the energy not only include the material itself, it also includes significant water consumption and resources and energy usage, as well as greenhouse gas emission. So when we need to produce timber, we need to consume energy, water, or other resources. So the materials consume energy and water in their removal, manufacturing, transportation, maintenance, and recycling, and produce hazardous emission during these processes. So not just the timber, but also the energy that we spend for extracting the timber from the tree, and then to process these timber into ready construction materials, and then to transport the timber to the construction site. So all these consume energy and produce the greenhouse gas. Okay, so we will talk about different kind of materials one by one. So first of all, concrete. The major environmental impact caused in the manufacturing of concrete derives from the use of cement, 水泥. So the manufacture of cement is responsible for between 4 to 5% of world's carbon dioxide emission, which is quite a lot, right? 4 to 5% is due to the cement. So cement substitutes, like the ground granulate blast furnace slag. So we may use these to replace cement. And there are also recycled concrete aggregate products available. So by reusing the concrete aggregate, we can reduce the carbon dioxide emission. Okay, timber. Timber is a very safe material to handle. So natural material, non-toxic, does not break down into environmentally damaging material, and the cladding can be reused if carefully dismantled. So the cladding means the panel. It is biodegradable and can ultimately serve as fuel source. So if the timber, so you torn down, a building is being torn down, and some of the timber can be reused. And even when the timber cannot be reused, cannot be recycled, we may burn it as a kind of fuel source. Untreated hardwood timber using hardwood can obtain a service life of between 40 to 60 years, which is very long. Okay, so for a wooden structure, if it is well maintained, then the structure can be very okay up to 40 to 60 years. Steel production has a number of impacts on the environment, including the air emissions of these gas. So the carbon monoxide, some sulfur oxide, nitrous oxide, PM2, and wastewater contaminants, hazardous waste, and solid waste. So when you produce steel in the manufacturer, you have to consume much energy. You have to use up much water, and in the manufacturing process, it produces many hazardous gas and waste. So to reduce its environmental impact, the structural steel should be reused so that it enters a new product use phase, but not just remelted when the building is demolished. Aluminium. It has a high strength to weight ratio. So comparing to steel, aluminium is much lighter. And it has excellent corrosion resistance. It also has good thermal and electrical conductivity. However, it would easily deform and has low resistance to fire. The production of aluminium consumes a large amount of electricity. The amount of energy needed to make aluminium is 211 gigajoule per ton, compared to 22.7 gigajoule per ton for steel. So making aluminium is 10 times more energy consuming than steel. Okay, so we have talked about different kinds of building material, the timber, the concrete, the steel, aluminium. So how can we compare their energy consumption? So we may use a term called embodied energy. Embodied energy is the amount of energy used to extract the material. We need to extract aluminium from the natural environment. We need to cut down the tree to extract timber. Okay, so energy to extract and to produce. So we need to use the furnace to melt down the steel and or the aluminium, and then to produce these material in the factory. So to produce and to distribute the material to the location of use. So maybe the timber that we used in Hong Kong is originate in the US or in the mainland. Okay, Hong Kong, we don't have timber. We have some countryside, we have some country parks, but we don't use timber in Hong Kong because we don't have forests. So we have to import the timber from the other countries, from the mainland. So the transport also consume energy. Okay, it is used as an indicator. So this embodied energy is used as an indicator to assess a material's environmental impact. Law Xiuchun, you raised your hand. You have question? Do you have question? I can put you to presenter, or you just accidentally click the button. Okay, so if you have question, you can type in the chat box. Okay, building materials with high embodied energy generate considerable amount of greenhouse gas emission. Reducing a material's carbon footprint will mitigate its environmental impact. So high embodied energy means that during the extraction, production, and distribution process, large amount of energy is being consumed. And energy also means carbon dioxide emissions. So greenhouse gas emission. So if we select the building material with lower embodied energy, then it means we are reducing the carbon dioxide emission and mitigate its environmental impact. So on the right-hand side, this is a graph based on the inventory of carbon and energy, which is in the US. Okay, so the embodied energy is not a universal parameter. So the embodied energy for timber in Hong Kong will be different from the embodied energy in the US or in the mainland or in Japan, because we need to consider the distribution costs also. So if the material is manufactured, it is produced locally, then the embodied energy will also be smaller. Okay, so this graph will only give you a reference. So aluminium, high embodied energy, and then steel, timber, and concrete. Okay, so this is just an example for the embodied energy, and the unit, megajoule per kg. Okay, rapidly renewable materials. So this kind of material is natural, petroleum-based building materials that have harvest cycles under 10 years. So less than 10 years, you can harvest this kind of material, like the bamboo. Bamboo is a natural composite materials with high strength to weight ratio, and it is useful for the structures. It is fast-growing plant. So some kind of bamboos can grow really fast. Maybe over a night, it can grow several centimeters. We may use bamboos for flooring, for wood boards, or for furnitures. Natural linoleum. It is made from natural materials, seed, recycled wood flour, cork dust, and so on. And they are usually used for carpet, floor covering. And cork, it is produced generally, it is treated as a sustainable material because the cork tree is not cut down to obtain the cork. Only the bark is stripped to harvest the cork. So only the surface is stripped. So the tree will continue to live and to grow. And then after some time, we can harvest, we can cut the surface to get the cork again. So the usage, we use it for acoustic and thermal insulation in the house walls, floor, ceiling, and facades, or even exterior facade panels. So like in this figure, this is the Portugal pavilion in the World Expo 2000. So they are using cork as the exterior facade material. And the Japan Pavilion in the World Expo 2000, they are using grid shell structure made out of recycled paper tubes that created a honeycomb-like buildings. So in the original design, this Japan pavilion rely on only recycled paper tubes, but the German authorities refused to allow a paper-only structure. So a secondary support structure made of wood was created to obtain the needed legal approval. So this is the Japan pavilion. So they use the recycled paper as a type of building material. And this is the Energizing Kowloon East office. They use recycled fringe containers and mild steel frame structure fixed by bolts and nuts. The building materials can also be easily dismantled and reused elsewhere at the end of the building's life. So this office is in the Guntong. So they make use of the used container as the structure of the buildings. The EMSD headquarters, another example. The EMSD headquarters was converted from the former air cargo terminal, Hector number 2, and it reduced most of the existing building material. So originally it is a air cargo terminal building, but they didn't demolish the whole building, but they turned it into the EMSD headquarters, reduced most of the building structure. So this is the original building, and they make it into the EMSD headquarters. And because of the reuse and recycling, $200 million are being saved in the project. Green wall and green roof. Okay, greenery on different levels of buildings reduces the internal heat gain and also provides a pleasant external environment in which to relax. So it mitigates the urban heat island effect. So urban heat island effect means that the air temperature in the city is significantly higher than the rural area around the city. So this is the urban heat island effect. So by incorporating more greenery to the cities, okay, more trees, more plants, then it can reduce the air temperature, because the trees will absorb the light, will absorb the heat, and then when the water evaporates from the leaves, it can also bring away the heat. And apart from mitigating the urban heat island effect, these plants, the trees, the greenery can also increase the local biodiversity and the wildlife. So green provides home for the birds and the insects and other living things. So vegetation and green space help reduce stormwater runoff. So stormwater runoff means when we have a thunderstorm, okay, heavy rain coming. So having more trees and plants can absorb the rainwater. So the water runoff needs to be handled by the drainage system, can be reduced. So it means that we can also prevent flooding. Green walls. So green walls, that is the vegetation growing on or against vertical surfaces. And they can be found outdoors or indoors on many types of buildings, like the hotel icons, in the office building, in the institutional buildings or shopping center. They can be incorporated into new construction or easily retrofit into existing buildings. Green walls have been divided into two main categories: green facades and living walls. So green facades means that the green wall is made of climbing plants growing on a wall, either with no additional infrastructure or with the use of stainless steel or wooden trellis, meshwork, or cabling as plant support. So one example is the Yonsei University in Seoul, the South Korea. So on the facade of the campus, they have these kind of ivy plants climbing the whole facade. So these kind of living walls, these kind of green facades, the green facades are historically set outdoor, rooted in the ground. So the plants grow from the ground and then climb to the upper part of the facade. And they don't require additional irrigation. Okay, because it is growing on the exterior and the roots, the plants is from the ground. So just by natural rain, it will provide enough irrigation. They can also be off the ground and erected indoor, usually freestanding with irrigation. So for interior, then we need irrigation. Okay, living walls. So we have green, we have the green facades and the living walls. Living walls are recently developed. So when we say green walls, we actually means the living walls. So they are recently developed, completely artificial system using continuous or modular planted up units. So this kind of green walls need the structure, needs the mounting of these plants onto the exterior walls. And there are different types. Okay, so in this figures, it shows 4 different types. So on the left-hand side, for interior or exterior, they may mount the plants, the pots of plants onto the exterior, and then they have the irrigation tank and the pump at the bottom so that the system can pump the water for irrigation. And for exterior, drip line at the top for irrigation. So on the top of the green wall, there could be pipe, water pipe, and then drip the water from the top to the bottom. And then at the bottom, they have the drainage bed. So the extra water will be drained away at the bottom. And 2 other exterior systems. So each panel contains drip emitters to ensure even watering. So instead of dripping from the top, so this is dripping from the top for this type, each panel, they have the dripping at different location, uniformly distributed in the green walls. So it provides even irrigation. And they may also have potted vines, so like the ivy vines in the green facade system. They have horizontal running drip line and drainage line, and so they provide the irrigation and drain away the extra water. So plants are rooted directly in the structure or in growth medium. So the growing media can be organic materials such as coconut coir, peat, tree bark, or some inorganic material. Depending on the system and the manufacturer, units are either pre-grown in the greenhouse or they can be planted on site once installed. So these are some examples for the interior living walls and also exterior living wall. Interior plant walls require supplemental lighting in order to strive and be sustainable over time. So if you put the plants inside the house, so depending on the type of plants, you need to provide enough lighting. Higher lighting level or lower lighting level could be could be adequate. So it all depends on the type of plants that you used. The lighting requirements. First of all, the lighting level. The plants need fairly bright light to survive. So they can survive with low light, but won't perform well and will lose their vigor and die over time. So generally, the recommendation is minimum 1,500 lux. So 1,500 lux is not too high, but higher than the general lighting recommendation for an office or for a classroom. So if you remember, for an office or for a classroom, the recommended lighting level for electrical lighting is 500 lux. So 1,500 is 3 times of the lighting level recommended for an office. So you need to provide extra lighting to light up the green walls. Color temperature, that is the color appearance of the light or the spectrum of the light. Photosynthesis is the process by which plants convert light into energy or sugar. So chlorophyll is the molecule in plants that reacts with light. And the chlorophyll reacts to specific wavelength of light. So chlorophyll or plant is green in color. So it means that the plant will reflect green light and absorb red and blue light. So in the spectrum, plant or chlorophyll will need the red and blue light. So if you have been to some greenhouse or some interior farm for plants, you will notice that they commonly use red and blue LED for lighting up the plants, because for the plant, they don't need green light. Instead, they need the red and blue light. Lighting requirements. So light distribution. We need to distribute the lighting uniformly on the green wall. So producing an even flood that does not have hot spots or cold spots on the wall is vital, important to the success of the interior green wall. If uneven lighting occurs, the wall's watering requirements will change. So when you light up a spot, when the lighting system is not uniform, so somewhere very bright, somewhere very dark, then the very bright part will be hotter because you have more light, right? So hotter, and water will evaporate faster. Then those plants may lack of water because the water evaporate, and no water for the life of for providing the water to the plants. So the wall's watering requirements will be affected, and we should light up the green walls as uniform as possible. So if you recognize, this is the green walls of Hotel Icon. So in the beginning, the Hotel Icon green wall is very pretty, but after some time, after some years, it becomes like this. So you have the rotted plants, and some died already. So it is due to the problem of the lighting system. Metal halide is used. LED is recommended. So commonly we use LED and metal halide to light up the green wall. And you may use a timer because they need to have 10 to 12 hours of light. So in the daytime, you have the daylight, but maybe the lighting level is not adequate. Then you need to provide supplementary lighting. And the lighting level should persist for 10 to 12 hours. Benefits of having outdoor green walls. So air purification. During the day, plants extract carbon dioxide. carbon monoxide and many other toxins from the air during the photosynthesis, and it results in significant reduction in the carbon dioxide levels. And the green walls will also reduce noise. Plant surface have low noise reflectivity, and it is a high absorption material. So ambient noise is attenuated by the ivy screens and living hoardings, improving the conditions for building occupants and pedestrians. So actually, we can just use the plant for the noise barrier. Okay, so many barriers in Hong Kong is actually very reflective. So instead of absorbing the sound, if they are using the reflective hoarding, then the sound will be reflected to other side of the road. So we are not solving the problem. We are just directing the noise to other direction. So we better use absorption material. Okay, dust suppression. A large area of greenery helps to suppress dust particles, improving air quality around construction sites and busy highways. This may lead to a reduction in the respiratory illness. So the trees are like the lungs of the city. It filters the dust, the toxins, and others. Okay, so having more trees will also reduce our respiratory disease and illness. Heat reduction. Urbanized areas have higher average temperature than the surrounding countryside, so increasing vegetation in city hotspots or urban canyons provides canopy cooling of trapped air and reduce reflected heat. Benefits of outdoor green walls. So some more like building protection. So when we don't, for the building facade, it may be bare concrete. It may be some tiles, maybe metal claddings. So anyway, these materials could be it may age, it may be damaged due to the sunlight. So the UV may damage the facade materials, especially the paintings and the tiles. So green walls cover the facade with plants and absorb the UV light. So green walls help reduce the UV damage to the surface, the building surfaces, and can protect the building from winds, weather, and temperature fluctuation, prolonging the life of the structure. So these factors could offset the maintenance costs of the green walls. So instead of maintaining the building facade, we can spend less money. We can spend less money to maintain the building facade when we have the green walls. Water management. So increasing the coverage of vegetation can reduce storm water. So this is especially useful in older urban areas where the excess storm water is combined with the wastewater system. So in the old urban district, all the water will be collected. So we collect the storm water, the rainwater, and also the wastewater to the same system. And then these wastewater need to be treated, need to be filtered. So if we can reduce the storm water, then the burden on these kind of treatment plant will be reduced. More advanced solutions can harvest excess rainwater for green wall irrigation, eliminating the need for a freshwater supply. Okay, so we may use some system to collect the rainwater and then save the rainwater for irrigation. Then we don't need the freshwater supply from the town main. Some more advantages, so I think you can read it yourself. And for indoor green walls, aesthetic, so it looks good, and it reduces the stress and mental health benefits. Improve air quality, sound insulation, okay, and temperature regulations. So green wall can regulate the building's temperature. So it means that it can absorb the heat, and therefore it can lower the energy cost for the air conditioning system. We have green wall, we have green roof. So green roof is the vegetation on the roof. So green roof is the roofing assembly consisting of waterproof membrane and additional component layers, including the growing media, the drainage, the root production, allowing for the propagation of vegetation across all or part of the roof surface. Green roof can be used in many applications, including industrial facilities, residence, offices, and other commercial property. Okay, green roofs can provide a wide range of benefits, such as reducing the heating, the cooling loads. So vegetation is a very good insulator. So by installing the vegetations on the roof, then you can reduce the heat transfer from the exterior to the interior, and therefore reducing the size of the HVAC equipment. Okay, so this is an example of the green roof in Hong Kong and the benefits for the green roof, and another example for the green walls in the Seoul City Hall and the residential high-rise building in the One Central Park in Sydney. Okay, we are running a bit late. Sustainable system, daylighting system. We can increase the window to wall ratio, or I should not say increase, we should optimize. Okay, too much windows doesn't mean it is good. Okay, when we have a very large windows, then there will be more solar heat gain and more energy have to be spent on the air conditioning system. So we need to we need to optimize the window to wall ratio to find out the right window to wall ratio, which is the best for lighting and also air conditioning system. So light shelf, we have mentioned this is the light shelf to reflect the lighting into the deeper part of the room so that we can reduce the energy consumption in the electrical lighting system. The skylight, the light pipe, and to make use of lighting control, we have a day lighting sensor or the occupancy sensor to control the lighting system. Air conditioning, the cross ventilation, wind catcher. Okay, wind catcher is just a system to capture the natural wind. Chilled beams. So chilled beams. So heat can be transferred by convections. So like my air conditioning system, supplying cool air to my interior, then it is cooling down my office through convection. But apart from convection, heat can also be taken away through conduction. So chilled beams is to use some cool down building elements to take away the heat. So the beams is cooled at a low temperature. So through conduction, through radiation, it can bring away the heat. Underfloor air supply system. So the occupants activities is usually in a low level. So air supply from the ceiling may be not too efficient. So instead of supplying cool air from the ceiling, we may supply cool air under the floor or through the floor. Then the air in the circulation zone will be cooled and it could be more efficient. Natural ventilations. So some recommended building layout, the openings, which can promote natural ventilations. Grey water recycling and rainwater harvesting. So grey water include the water from the bath, from the shower, wash basin, the kitchen sinks, or the laundry machines. So these are wastewater, but not too dirty, okay, unlike the water from the toilets. So they are called the grey water. So we may collect these water along with the rainwater. They can be treated, they can be sterilized, and then reused for non-potable purposes, like for toilet flushing, for irrigation, so that we can reduce the burden on the freshwater system. So the WSD is the Water Services Department, is planning to construct a centralized grey water recycling system at the Anderson Road Quarry development site for flushing use. Oops. Okay, sustainable system, some more example, biodiesel trigeneration. So it makes use of used cooking oil, so usually cooking oil for generating electricity. One example is in the zero carbon building. There is a cafe, and the cafe may have some cooking oil, and they also collect cooking oil from the restaurant around, so that they use the cooking oil for generating electricity. PV solar panels. So the PV solar panels convert solar energy into electricity, and for supporting the lighting system or other equipments. A solar thermal hot water system. So it uses a collector to concentrate the solar energy and then use it to heat up the water and provide the hot water for the building. Okay, so zero carbon building is a showcase of sustainable systems in Hong Kong. It is the first zero carbon building in Hong Kong, and it is developed by the CIC in collaboration with the government. So if you have time, or after all so when it is safe for going outside, I will highly recommend you to visit the zero carbon buildings. Okay, so I think I will stop at here. And after the lesson, when you have time, you can also visit this website. It shows you some green buildings examples, so that you can have more idea what kind of system, what kind of features we can use for green buildings. Okay, so I will stop.